Good afternoon, students, and welcome to our lesson today. How are you on this day, Thursday, 16th of May? I'm happy to take you through our lesson today. My name is Teacher Joyce Njaga. I'm a teacher in the KBA group of schools, and I'm located in Kahawa West, in the Kasarani sub-county in the larger Nairobi County. I'm a teacher of integrated science, pre-technical studies, mathematics, and English. But this afternoon, I want to take you through a lesson in integrated science. That will be our lesson for today. And just to remind us what we learned in grade 7, when you talk about integrated science, it is simply a learning area that has combined. To integrate simply means to combine. It is a learning area that combines several branches of science. Just to remind us, in grade 7 we learned that integrated science comprises of what we call biology. We also have the branch of science called physics, and we also have the branch of science called chemistry. And in there we can also include environmental studies. We also defined the 3 branches of science. The first one is biology, whereby we learn all about living things, that is plants and animals. The other one is physics, that has to do with energy. And the third one is chemistry, that talks about matter and everything about matter. Now today, our lesson, or our strand, the strand we'll be covering is what we, the first strand, which is elements. We'll be looking at what we, elements. Yes, it is on your screen. You can check your screen. Our topic for the day will be elements, mixtures, and compounds. That is our strand today, which is also called a topic. And the specific substrand that we'll be looking at is what we call the kinetic theory of matter. The kinetic theory of matter. And to start off, we'll be looking at what we already learned in our previous classes. When we were in grade 4, 5, and 6, even before we joined the junior school, we defined sometimes like matter. We came across a topic called matter. So I'll start by recapping what we learned in our previous classes. So, what is matter? When we talk about matter, what are we talking about? So, in our previous class, we defined matter as anything around us that has mass and occupies space. That was the definition of matter in our previous grades. And the definition has not changed. It is still our definition even today, that matter is anything that is around us that has mass. So long as it has mass. Remember, mass is the amount of substance in an object. The quantity of matter in an object is what we call mass. So long as an object has mass and it occupies space, that is what we call matter. In our previous classes, we went ahead to be told that matter exists in 3 states. There are 3 states of matter. That one we learned. We learned in grade 7, in grade 6 and 5. And the 3 states of matter are solids, liquids, and gases. The 3 states of matter are solids, liquids, and gases. Now, let's look at some of the examples of these states of matter. Some of the examples, you can have a look at some of the matter that we call solids, and you'll be looking at why are they solids in the first place. So if you look at your screen, you'll see some example of solids. I've given ice, there's a pencil there, there's an apple there. The others that are not there, like a wall, a table, even a human being is a solid. A stone, a piece of chalk, a pen, a duster, all those are solids. Then there are also examples of liquids there. We have water from the rain. Even the ones that are not on the screen, you know, there is blood, there is ink, there is milk, there is tea, all those are liquids. And then we also have examples of gases. Like we have water vapor. You can see some water vapor evaporating from a water body. As it evaporates, it is in form of a gas. You can also see some steam coming from boiling water. So steam is an example of a gas. You also have things like in a hot air balloon, whatever will make that hot air balloon to go up is because inside it there is air, and that is an example of a gas. Among others, like smoke, even what we cannot see. So wherever we are, there is air in our surrounding. So those are the examples of states of matter that we have. And now that brings us to our substrand for today, which is the kinetic theory of matter. That is what we are looking at today, the kinetic theory of matter. The kinetic theory of matter, that is our substrand today. And it is important for us to follow so that we understand exactly what is this. So again, I'll start with defining these terms. I know these are big terms. Talk about kinetic. There is the term theory. Already we have defined matter, so that one has no problem. So let me start by defining some of these terms. As you can see from your screen, I will start by defining the word theory, the term theory. When you talk about a theory simply is an idea or a set of ideas that explains facts. I can just call it in simple terms an explanation. It is something that tells us, why is this happening? Why does this happen the way it happens? Why does something exist the way it exists? So that is a theory. It is an explanation. It is telling us more about something. So when I give a theory, I'm trying to explain. Not only in science, even in life, there are so many theories. In other learning areas, there are so many theories. They are simply trying to tell us, why do things happen the way they happen? Why do things exist the way they exist? So that is what a theory is. The other term I want to define is the term kinetic. I want to define the term kinetic. When you talk about kinetic, or anytime you see the term kinetic, kinetic simply relates to movement. Movement or moving, something that is in motion. So long as there is motion or some movement in an object, that object can be said to be in a kinetic state. For example, if you go to a fall or a river, the water in a river is flowing. The water in a fall is flowing. There is some movement. So we can say that water contains kinetic energy. So kinetic has got to do with movement. When you kick a ball and that ball is moving, so long as there is that movement, that ball contains kinetic energy. So that is the definition of kinetic. Has to do with movement, motion, or something that is moving. Now that we understand the terms that have been used in our subtopic, we already defined matter, meaning we already know what matter is. We have just said, just to remind us that matter is anything that has mass and occupies space. Now we know the definition of kinetic, we know the definition of theory, and we also know the definition of matter. Now, let's get to the definition of the whole thing. When we talk about the kinetic theory of matter, what are we talking about? And that brings us to our next slide. That I want to define the kinetic theory of matter like a theory, or it is an explanation. It is an explanation about the existence of the three states of matter. We have already said that matter exists in three states. So this theory will explain how does the matter exist in the three states. This theory also states that matter is made up of small or tiny particles, and maybe to bring other terms, these particles could be either atoms or molecules. I know we have learned about them. An atom is the smallest particle that can exist, and then molecules are a combination of atoms. So these small particles are held together by what we call forces of attraction. So the particles are held together by forces of attraction. So that is what the kinetic theory is talking about. How are these particles in matter held? I'll go ahead to talk more about the kinetic theory. It should also tell us how are these particles. Now that we are saying matter is arranged is made up of small particles called atoms and molecules. Now the theory is to tell us how are these particles or small particles or tiny particles arranged in each and every state of matter. So we'll also be looking at the arrangement of particles from one state to the other. So we are saying the arrangement of these particles varies from one state to another. We'll be seeing as we continue. The small particles also have spaces between them. Like we'll also be seeing as we move on in some diagrams here and there. So the theory will explain to us how are these arrangement of particles. How is this arrangement of particles, or how does it affect the way the three states of matter behave? How do they determine the properties of the three states of matter? And how are we able to change matter from one state to the other? So I want us to look at the arrangement of particles in the three states of matter as explained by the kinetic theory of matter. So on your screen, I want you to look at what you have on your screen. The subtopic there is arrangement of particles in matter. The first part or the first diagram, you can see a solid. I know you can just see balls there. I'll be explaining what those balls are all about. The second diagram, there are some balls inside a container, and the subtitle there is a liquid. And in the third one, there is a box that seems to have balls that are scattered all over. Again, I'll be explaining what is that is all about. So the next diagram is the explanation of what you have just seen on our screen. So the first diagram we saw was the particles. How are particles in a solid arranged? And if you are to go back to the diagram, the arrangement in a solid, like we can see, there is some regular pattern. You can see they are actually forming something like a triangle. In the next slide you'll be seeing the arrangement of particles. When you look at those diagrams, there is a very particular shape, a very regular pattern of how those particles are arranged. And I'll be explaining why it is like that. So what we are saying is that in a solid, there is a regular or a fixed arrangement of particles. Yes, so the arrangement of particles, you can see on your screen, there is a regular pattern, and our pattern, like shown down there, is taking the shape of a rectangle, because that is how those particles are arranged. The particles, again, as you can observe, they are very well close to each other. Very close to each other. Then, when you go to the next diagram of a liquid, there is a change. Those particles now are no longer in that regular pattern. You cannot have that shape. Now the shape is irregular. They are all over, they are scattered, but still they are close together, though not as close as they were in a solid. Then the third one is a gas. Again, no particular pattern. The particles are scattered, and actually they are far apart. There is a big space in between them. That is how the particles are arranged in the three states of matter. Now, having looked at the arrangement, again, let's see, how do the particles move? Are they able to move one pass to the other? Now we go back to the solid. We have seen the particles in the solid are close together and they have a regular pattern. And because if you observe closely, there is no much space in between them, it means these particles are not able to move. They are not able to move from one place to the other because they have to be in that regular pattern. The only thing the much movement that can happen in between solids is just vibration. They cannot move front, sideways, or whatever way. They can only vibrate in their fixed positions. Let me bring an example closer home. I know as Kenyans, we like knowing what is happening. Suppose something happens by the roadside and everybody wants to go there. You want to find out what is happening. Within no time, there is a big crowd in a way that there is no any space in between. People are so packed together. When such a situation arises, you realize if you are in that crowd, you will not be able to move to whichever side. You are fixed in whichever position you are. The only thing that you can do, you find yourself maybe just being swayed by the crowd, but you are not able to move. I think that should explain how the particles in a solid are. They cannot move from one place to the other. They will only be able to vibrate in their positions now that they have no space between them. Let's look at the gases. We go back to the diagram again. We look at the liquids. They have an irregular shape. And if you observe, they are close together, yes, but not as close as they were in a solid. There is at least a bit of space in between them. So what is the implication of that on how the particles are able to move? Now, in a liquid, the particles are able to move. They can move past each other. They can slide past each other. They can move in different directions. They are able to even flow. They can flow from one place to the other. No wonder liquids can flow. When you have water in a bottle and you want to put it in a cup, that water will flow from the bottle into your cup because the particles that make up a liquid are able to allow that liquid to flow. They are able to allow that liquid to flow by the fact that they are not so close together. They can move and they can flow. That is a liquid. Same to the same scenario I had brought before that. If you are in a group of people but there is space between us, at least a bit of space, you can move a bit. You may not be able to move so far, but you are able to move because there is a space in between you. So that is how liquids behave. They are able to move a little bit. They are able to slide past each other. They are able to flow because there is a bit of space between them. Finally, let's look at the gases. How are particles arranged in a gas? Now, in a gas, we can see the irregular patterns. The particles are very far apart. There is a lot of space in between them. There is a lot of space in between them. So that means these particles are able to move quickly. The key term there is that they're able to move quickly. They can move very fast. They can move in any direction. They are able to move randomly in whichever way they want. That's why if I was to give examples, when a fire is burning and that fire happens to have smoke, the smoke will be able to move. Or you see it moving up the sky to a very far distance because the particles in that air or that gas, an example being smoke, is able to move by the fact that the particles are not close together. Again, by the example I'm giving of people together, for example, I'm alone here. I have all the space. I can move whichever direction I want to move. I can move at whatever speed I want to move because there is space. Whichever side, if I want to move faster, if I want to move slowly, if I want to move quickly, I'm able to move because there is a lot of space around me. Then that is how gases will behave when it comes to movement. So that is how the particles are arranged, and that is how they move. And I want us to see further, how does this movement or how is this kinetic theory applying in all the states? So I'm still further explaining in the next slide about the movement of particles in the different states of matter. Now, when you look at what is on your screen, the first diagram, which is green, we are talking about the kinetic theory explains the difference between the three states. I already stated that. Now, if you look at the first diagram, in solids, we are saying the particles have low kinetic energy. I already said what kinetic energy is. It is about movement. It is about movement, meaning if we say that solids have low kinetic energy, it means there is little or no, almost no movement between the particles. This is because the particles in solids are held together by what we call intermolecular forces of attraction. Remember, that is what we started by saying, that these particles in the three states of matter are held together by forces of attraction. They are forces that attract the particles, the molecules, to each other. So in a solid, these forces of attraction are so strong in a way that there is very limited movement. The arrows are showing the bare movement, the little movement that can happen, which is just vibration. The next diagram, which is in red, showing liquids, again, we had already seen the particles. These ones now, there is some space. So we are saying in liquids, the particles have more kinetic energy to stretch that force of attraction. So they have more space to stretch. Meaning now these liquids are able, that's why the liquids are able to move, like I have explained. They are able to flow. They are able to move in different directions. They are able to make more movement, although not so much as compared to liquids, because the energy, the kinetic energy in them is more than that is in solid. And finally, we have the gases. You can see the diagram in blue. Those particles in gases, the particles have enough kinetic energy to break all the intermolecular forces of attraction. That means because the gases have this kinetic energy, they can move as far as they can because of the space in between them. It means the gases can flow without any regulation. They are able to move without any distraction, without any limitation. So gases are able to move freely, like we'll be seeing. Now, that brings us to our next slide, which we'll be looking at what we call properties of matter. Now that you have understood what kinetic theory of matter is, this kinetic theory of matter, or the arrangement of particles in the different states of matter, will determine how matter behaves, how matter moves, how the different aspects of matter, how solids behave, how liquids behave, how the gases behave, is simply determined by the kinetic theory of matter, by the arrangement of particles in the three states of matter. And that brings us to properties of matter. That brings us to the properties of matter. We want to see how matter behaves and why it behaves the way it behaves. So properties of matter. When we talk about properties of matter, the three states of matter have different properties, like I've just said. And these different properties depend on the arrangement and the movement of particles in matter. We have already discussed that. We have seen how particles are arranged in a solid. We have seen how particles are arranged in a gas. We have seen how particles are arranged in a liquid. We have also seen how these particles are able to move in different states. Just to remind us, we are saying in a solid, the particles will move actually they are not able to move. They are only able to vibrate in their fixed positions because they are close together. In a liquid, the particles are able to move because there is at least some space between them. And in a gas, there is a lot of space in a way that the gases can move freely the way they want to move. So what you are saying, what we have just discussed, is determining the the properties of matter. And which are these properties of matter we are talking about? There are several properties of matter, but the ones we'll be discussing for now are 5. The first one is shape. Shape is a property of matter, and different states of matter have different shapes. We'll be seeing how the kinetic theory affects this. We'll also be discussing volume. We'll also be discussing ability to flow. I've already said liquids can flow, and the reason why they are able to flow is because there are spaces in between them. Their particles are not very far, they are not very close together to each other. They create space for the liquids to flow. And then we'll be looking at compressibility. Compressibility simply means is a certain state of matter, is a certain object able to give into pressure. When you apply pressure on an object, is it able to give into that pressure? Will it crash when subjected to pressure? That is what compressibility is. We'll be looking at that, and then we'll be looking at density. How does the arrangement of the particles in the different state of matter determine these properties of matter? So for today, we'll be looking at the first property, which is shape. The first property of matter is what we'll be looking at today, which is shape. Let's see how the kinetic theory of matter affects the shape of the different states of matter. So the first one we'll be looking at is solids. Let us look at the shape of solids. How are solids shaped? And there's an activity. The activity which we can use to determine this, we can have a stone. You take a stone, any stone. I know stones are available outside there in your houses, and if the stone is not available, there are other solids. Then you hold that stone in your hand. Then after some time, you can place the same stone on the table. You can even place the same stone on the floor and anywhere else you want to place it. And then you make an observation. Like now, I want to use a solid I have. I have a duster with me here. This is a solid. Now that I don't have a stone, this is a solid. I'm holding it in my hands. Observe the shape. Observe the shape. I'm holding it in my hands. This is a duster. It is an example of a solid. The same duster, I place it on the table. Observe whether the shape has changed or not when it is on the table. I can still take the same duster and even lift it up. Observe the shape. When you look at that, we can see that the shape of the duster remains the same no matter where you place it. In my hands, it was the same. On the table, it is the same. When I lift it up, it is the same. If I pick it and place it on the floor, the shape will not change. It will remain the same. So what are we saying about solids? We are saying that through that activity, we can conclude that solids have a fixed shape. You can see on our screen, there is a conclusion there. We are saying the shape remains the same no matter where you place that solid. This shows that solid have a fixed or a definite shape. When we talk about a fixed or a definite shape, something definite is something that does not change. It cannot keep on changing simply because you have changed the position. So our conclusion in that is that solids have a fixed shape because their particles are tightly packed together and held by strong forces of attraction between them. I've already explained that. I don't need to go back to that. The only way you can change the shape of a solid, for example, if I want to change the shape of a stone, unless I take something which is heavy like a hammer, and then you hit it hard, you crush it. But normally, the shape of a solid remains the same. And the explanation is because of the forces of attraction, because of the kinetic theory of matter. The particles are closely packed together. meaning they cannot just move anyhow. They can only vibrate in their fixed positions. We look at the next state of matter, which is liquids. We can look at liquids. Let's see how liquids behave when it comes to shape. Let's see how liquids behave when it comes to shape. Now, when you take a liquid, for example, water. Yes, we can observe your screen. When you take a liquid like water, and in this one I would prefer you use colored water so that you're able to see. You pour that water into containers of different shapes. For example, you can use a conical flask, you can use a round bottom flask, you can use a test tube, you can use a beaker, you can use a volumetric flask, you can use your water bottles. I know you have so many water bottles at home and they take all the shapes. When you go to a supermarket or a shop and you look at the water bottles, they come in all shapes, in all sizes. Now, if you take some water or some liquid and you pour it into a container, that is the activity, what will be the observation? You realize that that liquid, whatever it is, be it water, be it juice, be it ink, be it tea, even, there are so many shapes of different shapes of cups, you realize that that liquid will take whatever the shape that container is. It will take whatever the container. Actually, there are some containers which are very different shapes, very funny shapes. You find a bottle, especially those ones for very young children, they have very funny shapes. Or even the one for soda, like Fanta. And for example, you have a bottle shaped that way. When you put a liquid in it, the liquid is able to move and take, even if it is a circular, then whatever the shape it is, the liquid will move. It is able to flow. If another one has corners, for example, I assume these are water bottle of someone who is watching this. These are water bottle. Again, I put some liquid. The liquid is able to flow up to all the corners. Why is it able to do this? The liquid is able to take, it will actually take that shape of the container as it is. It is able to move and take that shape of the container. So what are we saying about this? So from this, we can make a conclusion. You can look at the conclusion on your screen. We are saying liquids do not have a fixed shape. They do not have a definite shape because their particles are not tightly packed. And because they are not tightly packed, it means there are some spaces in between them, so they are able to move. They are able to slide past each other. They are able to flow. No wonder they will enter even in those corners to take the shape of whichever container they are placed in. So our conclusion again, we are saying is that liquids have an indefinite or a shape which is not fixed. Let's look at the gases. Let's look at the gases. We look at the gases. How do they behave when it comes to the shape? And again, we'll be looking at an activity. Which activity can we use when we want to look at the properties or the characteristic of gases when it comes to shape? Now, let's observe our screen. There is an activity there, and the activity to do so that we can conclude on the shape of gases, we are supposed to blow air into balloons. We inflate balloons by blowing air into them. When we blow air into balloons, and these balloons, the requirement is that they should be of different shapes. There are so many balloons. There are those that are round, there are others that are star, others take the love shape, the heart shape, others, there are even those that are worn by children when they go out there to play. So there are so many different shapes of balloons. So you are supposed to inflate these different shapes of balloons, and after inflating them, you tie at the opening with a piece of thread. Why are you tying? Of course, you are tying so that the air that you have blown into them will not escape. And that way you are able to make your observation. Now, let's see the observation. When you look at that observation, when air is blown into the balloons, it takes the shape of the balloon as shown. You can see we have quite a number of balloons. The first one, the second one is in the heart, the shape of a heart. We have some round ones. We have some star. We have so many shapes. Some of them I don't know which shape they are, but you can see them. So all of them have different shapes, and that air has entered that balloon and has taken up again the shape of the balloon. Why is this? Again, it is taking us back to the same thing. That balloon, that balloon, for example, the most common balloons are the ones that are round. They are round. When you blow in air through the opening, through the mouth, that air, because the particles in them are very far apart, the air is able to flow to all corners of that balloon, depending on how it looks like. So the conclusion we make on that is that air does not have a fixed shape. Air does not have a fixed shape. Instead, it takes the shape of the container. And in our case, the container is the balloon. The air will take the shape of the container in which it is placed. Whatever the shape that container is, that is the shape that the air will take, simply because it has no fixed shape. So, that one, what are we saying in short, is that how the particles are arranged in matter determines our properties. And the first property we have looked at is shape. So we can make a conclusion. We can make a conclusion of the whole lesson. We'll be looking at the other properties as we continue with in the subsequent lessons. So the conclusion we are making, it is on your screen. So the conclusion we can make from what you have learned, one is that solids have a definite shape. And the reason why they have a definite shape is because the particles in them are very close together in a regular pattern, and it cannot be distorted anyhow by just changing the position from one position to the other. And because of that closeness, that regular pattern or that regular arrangement of particles, the shape in solids remains the same. The second conclusion we can make is that liquids and gases do not have a definite shape. And we have looked at activities that we can use to determine that. We have seen water taking the shape of a bottle, the bottle in which it is placed. We have seen it. If the bottle has circles, that is the shape it will take. If the bottle has corners, that is the shape it will take, because it does not have a definite shape. We have also seen the same in gases. The gases will also take the shape of the container, or the container in this case in our activity was a balloon. And therefore we can make one final conclusion that the shape that a material takes, is simply determined by the arrangement of particles in the three states of matter. And that is what we call the kinetic theory of matter. So, students, we come to the end of our lesson today. In our next lesson, we'll be looking at the other properties of matter that I've already mentioned. That is density, compressibility, ability to flow, and also volume. Keep on revising so that you are able to keep up with the content in integrated science, which is a very interesting learning area. Have a good afternoon. See you next time. Bye.